In section 5 of chapter 5, we are now moving on to solving rational equations. First, I want to do a little old school review of what we have been doing with solving equations. Problem number 1, this is just a straight linear function, linear equation. I'm just going to subtract the 1 from both sides, get 2x equals 4, divide by 4, divide by 4. You can do this pretty much, divide by 4, divide by 2. You can pretty much do this on autopilot, I say as I did that wrong, and you can derive the correct answer. It's no big deal. Problem 2, same thing. I have x divided by 5, all minus 6 equals 0. We'd add the 6 to both sides. X divided by 5 is equal to 6. Multiply both sides by 5. And we get x is equal to 30. Yay, done. Those two should not be a shocker. Here's where it gets a little bit different though, because in the first two problems, x was taking on a passive role. Things were being added and subtracted to it. Things were being multiplied or divided into it. Things were happening to the x value. Problem 3, x is no longer taking a passive role. It's taking an active role in the equation. X is the thing we are dividing. So we got to approach this a little bit different. Here's the way that we're going to do this. You're going to look at every single term in the entire equation, left and right. You're going to look at it and say, all right, what is the common divisor between all of them? Between x, 3, and 4. The common divisor is 12x. So what we're going to do is we're going to multiply the entire equation by that common divisor. Because something special happens when you do that. If you multiply the 12x times x, realize that 12x is the same thing as 3 times 4 times x. If you multiplied the 12x times 2 over x, the x on the bottom would cancel with the x on top, and you'd be left with 2 times 3 times 4, which is 24. Plus, when we distribute this 3 times 4 times x to the 1/3, the 3 on the bottom would eliminate with this 3 here, leaving you with just the 4x. So it just becomes 4x. Equals, lastly, we distribute the 3 times 4 times x to the third and final term. The 4 on the bottom would eliminate with the 4, leaving you with just the 3, the x, and the 5. So that'll give you 15x. And then we solve. Now it's like the first two problems. We're going to subtract the 4x to both sides. That'll give me 24 is equal to 11x. Now it's not going to be pretty, but I'm going to divide both sides by 11. And I'll get my answer of x equals 24 over 11. Are we all good with this that I've done thus far? Yeah? Thumbs up, we're doing good? Yeah? Cool. Because I did something wrong. I'm not going to reveal what I did wrong right now. I'm going to go to the next slide. This is what we're doing today. I'm going to be solving these rational problems. I'm going to do the exact same process. In fact, the first one is pretty much the same problem. I'm going to take the entire equation. Ooh, that mark is way too big. I'm going to take the entire equation, and I'm going to multiply it all by x times 3 times 2, if you want to do that, or just 6x. When I multiply the 6x times the first term, the 2 over x, the x's would cancel. 6 times 2 is 12.
Wait, how do you get 6x?
Then I multiply the 6x times the 1 over 3. The 1/3 would turn the 6 into a 2, so I just get left with a 2x. Equals 5 over 6 times 6x. The 6 on top and bottom would cancel, and you're just left with 5x. Subtract the 2x from both sides. And you get 12 is equal to 3x. Divide by 3. Divide by 3. X equals 4. Thumbs up. You guys good with this? Because I made the same mistake again. I will tell you what the mistake is on the next problem, but I want to give you all a chance. Before I go on to problem number 2 and show you what the mistake is, I want to remind you of something I told you earlier this year. There are 2 things in Algebra 2 you're never ever allowed to do. We're going to actually address one of them later this year. The other one you'll address in calculus. The 2 things you were not allowed to do previous to this class is you were never ever allowed to square root a negative. We kind of slightly addressed it, but we're going to do a full chapter on complex numbers later. The second thing you're not allowed to do in mathematics is you're not allowed to divide by 0. That's what this is going to be talking about. I have rational equations and rational expressions. That means a variable's in the denominator. If there's a variable in the denominator, there's a possibility, depending upon what x is, there's a possibility I might actually end up dividing by 0. You need to address that. Problem number 2, and I'll show you why that's important. Problem number 2. Same thing. I'm going to multiply everything by the common denominator. The common denominator here is x times x minus 2. When you distribute that, the first term just becomes 10. The second term becomes 4 times the x minus 2, which is 4x minus 8. And then when I multiply the 5 over x minus 2 by that common denominator that I have written in black, the x minus 2's cancel, so you just get 5 times x, which is 5x. Solve. So I'm going to subtract the 4x to both sides. 10 minus 8 is 2. Then 5x minus 4x is x. So my answer is x equals 2. I made the same mistake again. But in the last 2 problems, me making that mistake didn't actually have an effect on the problem. Here it does. Because I just found out the answer is 2. If the answer is 2, then I should be able to plug it back into the original equation and get a true statement, yeah? Let's try that. Let's take that 2, plug it back into the original equation. Let's see if I get something like 4 equals 4. If I do that, I'm going to get 10 over 2 times the quantity of 2 minus 2 plus 4 over 2 equals 5 over 2 minus 2. That gives me 10 over 2 times 0 plus 4 over 2 equals 5 over 0. That means 10 divided by 0 plus 4 divided by 2 is equal to 5 divided by 0. Hopefully at this point you should see the issue. You can't divide by 0. 2, even though I calculated it should be my answer, makes me divide by 0. This is what we call an extraneous solution. We have to exclude it from our list of possible solutions. The step that I did not do, which is fine that you didn't see it because it should not have been shown to you previously, is when you're dealing with rational equations, if you have a variable on the denominator, once you have everything factored, just like how we found x-intercepts, we now need to find what are called extraneous solutions. We need to find what x can never be equal to. In this problem, x cannot be equal to 0 or 2. These are extraneous solutions. The reason it was okay to make that mistake in the first problem is our extraneous solution was x cannot be equal to 0. Our solution did not match our extraneous solution. So that was okay. We weren't going to divide by 0 with that answer. But in this problem, if we say our answer is 2, that matches one of our extraneous solutions. What we have to do is cross that out and say no solution. Now here's what's also really important for me as a grading perspective. Do not do this. I still need to see that you got x equals 2. I still need to see that you cross it out. But if you just really scratch it out, I won't be able to see it. You need to show me that you calculated x equals 2 as your solution, and then the line through it tells me you recognize it matches your extraneous solution, and then you need to tell me there is no solution. This is not like square roots. The answer is not no real solution. There is no solution. Nothing. There's no imaginary or real solution. This thing has no answer. For problem number 3, this one's a little different than the ones I just got done doing because, surprise, surprise, it's not factored in the denominator. First step, make sure the denominators are factored. Then you can list your extraneous solutions. So, this is going to turn into x over x minus 1 times x plus 3 plus 1 over x times x plus 3 equals 1 over x times x minus 1. Now that I have this factor, now I need to basically find the x-intercepts for the denominator. Those are my extraneous solutions. For this one, that's when x is equal to 1. For here, this is when x is equal to negative 3, when x is equal to 0, when x is equal to negative 3, when x is equal to 0, when x is equal to 1. So as a list, x cannot be equal to 0, 1, or negative 3. Now, more often than not on these problems, your extraneous solutions won't do anything. They're just the numbers you're not allowed to have as answers. More often than not, your answers you calculate will not match up with these. But on the rare occasion they do, you need to have this written. I circle it because it's important, but it's not the answer. All right, now that I've done this, I can multiply everything by the common denominator of x times x minus 1 times x plus 3. Kind of ran out of space. I distribute it to all 3 of them. When I distribute it to the first one, the x minus 1 and the x plus 3 would eliminate, and you're just left with the x. X times x is x squared. When I distribute this to the second term, the x and the x plus 3 would eliminate, just leaving you with the x minus 1. X minus 1 times 1 is x minus 1. Equals. When I distribute this common denominator to the third term, the x and the x minus 1s would eliminate, just leaving you with the x plus 3 times 1, which is x plus 3. I have an x to the second power, and I have an x to the first power. That means this is a quadratic. The only way to solve quadratics is to either factor it or use the quadratic formula. Both of those require that I need it equal to 0. So I'm going to take the x plus 3 and move them to the left side of the equal sign. Subtract x, subtract x, subtract 3, subtract 3. That way this turns into x squared minus 4 is equal to 0. You can use the area model, you can use the quadratic formula, you can use the diamond method, you can use the tick-tock method, whatever method you want to factor. You could also realize that's a difference of squares. That's just going to turn to x plus 2 times x minus 2. Those all work. I'm going to stick with algebra. I'm just going to add the 4 back to the other side. Get x squared equals 4. Square root both sides. Don't forget the plus or minus. And get my final answers of x equals plus or minus 2. I need to double check. Do either of these answers match any of my extraneous solutions? No. So those are my answers. And I am done.